Okay, this is Wednesday, 420. Is it 25? 425. Notes. On a unit circle, the radius is 1, and therefore the hypotenuse of each of the triangles is also 1. So let's look. So if you just did say a 30 degree of the unit circle, then this is 1. Okay? Now in this right triangle right here, this is the x-coordinate, and this is the y-coordinate, but we know the radius is 1. And that goes for 30, 45, or 60. It's the same situation no matter what triangle you draw. So if you write this as an ordered pair, it's x, y, right? And then the tangent is the y-coordinate over the x-coordinate. So remember that your ordered pairs are in the format cosine, sine, and the tangent is sine over cosine. So keeping all this stuff in mind, look over here. The sine of any angle of a unit circle. I said 30 right here, but we could just say this is theta. The sine of any angle in a unit circle. The sine is always the vertical distance, the y. It's the second one in the ordered pair every time. Now the cosine is x. That's the adjacent side. Okay, it's the adjacent side. Theta is right next to it. So the x always goes with cosine. And notice that your cosine is the x-coordinate of the ordered pair. Right there. Tangent is y over x. Which means that the cosine, since this is really y over 1 and this is really x over 1, the cosecant is 1 over y. The secant is 1 over x, and the cotangent is x over y. So let's think of 30 for a second. 30 degrees in a unit circle. As the ordered pair, radical 3 over 2, 1/2, and the tangent is radical 3. So this is cosine, sine, and tangent of 30. There's your answers right below it. So what would the secant of 30 be? It'd be the reciprocal of this one, 2 over radical 3. Let's not even worry about rationalizing. What is the cosecant of 30? What's the reciprocal of 1/2? 2 over 1. What is the cotangent of 30? It would be 3 over radical 3. Those would be your 6 answers. Now, if you wanted to rationalize this one, you would multiply by radical 3. So technically, this is the better answer for secant of 30. And on this one, if you rationalize cotangent of 30, you'd get 3 over radical 3 over 3, which is just radical 3. Is that a lot what I just said? Remember that all scholars take calculus, or in this quadrant, everything's positive. And this one, only sine is positive. And this one, only tangent is positive. Tangent's on the outside. And in this one, only the cosine is positive, which is the first one. So that means that if sine is positive, so is cosecant, because they're reciprocals. So sine and cosecant are both positive in this quadrant. Tangent and cotangent are both positive in this quadrant. So here, that's positive, and so is cotangent in the third quadrant. And cosine and secant are positive in the fourth quadrant. Everything else is negative. So use this unit circle to find the sine, cosine, and tangent for 135. Let's draw a unit circle. 135, here's 90, it's halfway right here. That's 135. But if you're going to try to make a triangle, 135 is too big. So we want to do the reference angle. So we're going to take 180 minus 135, and that gives us our 45. This is 45. So it's a 45, 45, 90 triangle. If you look at your unit circle from yesterday, the ordered pair for a 45 is right here. The 45 is right here. But we also have the unit circle. We can look at 135. There's 135, right? Let's go ahead and write this down. This whole thing right here. We're not even going to do 45. Let's do 135. 135, you have negative radical 2 over 2, positive radical 2 over 2, and negative 1. I'm getting that right from my unit circle right here. 135. See it? Red right there. Now, This is the cosine. So if I said, what is the cosine of 135? It's the first one, negative radical 2 over 2. If I said, what is the sine of 135? It's the y-coordinate, which is positive radical 2 over 2. And if I said, what is the tangent of 135? You would say negative 1. These are your three answers, just looking at the ordered pair from your unit circles. Cosine, sine, tangent. So it says, use the unit circle to find the following. Cosine of 120. Okay? So I'm going to write down the ordered pair for 120. 120, let's find it. There's 120. You see it? This is the ordered pair. So it's negative 1/2. I'm not even going to write the tangent unless it asks for it. So this is the ordered pair for 120. Because we want cosine, this is your answer. That's it. Oh my God, you can't see that. So sorry. This is the ordered pair for 120 right here. So we want cosine. So we want the first one, negative 1/2. So somewhere you need to write down that the ordered pairs in this format, in this order. Cosine, sine, tangent. So the next one we want is cotangent of 210. That's the reciprocal of tangent. So we're going to find the tangent and then flip it over. So let's find 210. 210s right here. See in the green? This is the ordered pair, but this is cosine, this is sine, this is tangent. So the tangent, I'm going to write down, the tangent of 210 is in the circle. It is radical 3 over 3, and it's positive. But we want the cotangent. So the cotangent of 210 is the flip of this, which is 3 over radical 3. I can even write this bigger over here. That's good. So the cotan of 210 is the flip of tan of 210, which is 3 over radical 3. Now if we rationalize this, we get 3 over radical 3 over 3, which is radical 3. That's the cotan of 210. Sine of 315. Sine of 315. Here's 315 in red. So remember, it's cosine, sine. So what's your answer? It's negative radical 2 over 2.
Literally 54 seconds. He gets 3,000 likes and 2,000.
What is the tangent of 120? Let's find 120. Here's 120. See it? Tangent 120, negative radical 2. What is the cosecant of 315? Now cosecant is the reciprocal of sine. So I'm going to find the sine of 315 first, and then we're going to flip it. Okay, so let's find the sine of 315. Here's 315. Sine is the second one. It's negative radical 2 over 2. Let's write that first. That's what the sine is. We're going to flip it because we want the cosecant. So if you flip that, it's going to be negative 2 over radical 2. I think we should rationalize. So it's negative 2 radical 2 over 2. 2's cancel, and your answer is negative radical 2. That is the cosecant of 315. Secant of 150. That is the reciprocal of the cosine of 150. So the cosine of 150, find 150. Here's 150. The cosine of 150, it's in the green, is negative radical 3 over 2. But we want to flip this because we are looking for the secant of 150. So if we flip that, it looks like this. Rationalize, and you get negative 2 radical 3 over 3. That is the secant of 150. Cosecant of 90 is the reciprocal of the sine of 90. So what's the sine of 90? Sine of 90 is 1. Remember, it's cosine, sine. See right here? Cosine of 90, I'm sorry, sine of 90 is 1. What's the reciprocal of 1? If you flip 1, it's still 1. Now there is a way you can do that on your calculator. The ones that don't involve radicals, you can do on the calculator. So if you punched, make sure you're in degrees. Make sure your mode's in degrees. This calculator, the mode was in radians, so I'm going to switch it to degrees. Press second mode. Okay. So if I pressed in sine of 90, you get 1. And if I want the reciprocal of that, you press this button right here. X negative 1 is the reciprocal key. Press that, and it flips the 1, and it's still 1. That's why your answer is 1. I'm switching to red. Cosine of 270. That is not a flip. That is an actual ordered pair. So cosine of 270. Here's 270. The cosine is the first one. It is 0. Your calculator will give you that. That's cosine of 270. The ones that don't give you radicals, you can check on your calculator. Tan of 180. Here's 180. The tan of 180 is 0. That means your calculator will give you that answer. Tan of 180. 0. Cotan of 270. Well, this is not one of our 3 main ones. So we're going to find one of the main ones that go with cotangent. The reciprocal of cotangent is tangent. So we're going to find tangent of 270. This is 270 right here. So the tangent of 270 is undefined. So if you flip this, undefined, what that means is that it's 1 over 0. That's what undefined means. It means the zero's in the bottom. So if you flip this, the reciprocal of undefined is 0 over 1, which is 0. The reciprocal of undefined is 0. Your calculator will not give you this answer. You're going to have to know that. So, trig functions, turn it over. Trig functions have an angle and standard position. When given an angle and standard position and a point on its term of side, it is very simple to find the 6 trig functions of an angle. It says first, plot the point. Okay, we're doing that first. Here's a point, 3, -4. Plot it. Right 3, down 4. That's our first step. Plot the point. Step 2, draw the terminal side of the angle by drawing a ray from the origin through the point. So this is our hypotenuse of the triangle. So we're going to go from the origin and we're going to draw a ray through the point like that. Step 3, connect the point to the closest, I'm going to write the word closest, to the closest x-axis. So would it be this axis or this one? This one's closer, so we're going to this one. And we're going to form a right triangle. So from the point, don't go from the arrow, go from the point. Go up here and form a 90-degree angle with the closest x-axis and put in a square. That's a 90-degree triangle. Step 4, theta, we're going to fill this in. This is a 90, but this is not theta. Theta is the acute angle formed with the x-axis and the hypotenuse. So that's right here. Put in theta. Step 5, label the sides of the triangle using the point. Don't forget, negatives if you move backwards or down. X goes along the horizontal, Y is the vertical. So in this point, 3 is the horizontal. So you had to go right 3. That is right there. 4 went down. That's why this is -4. So we have 2 sides of our triangle. The ordered pair is 2 sides of your right triangle. Now we're going to use our old Pythagorean theorem to find the hypotenuse of the triangle. The hypotenuse, notice right here, is always positive, no matter what. So when you do the Pythagorean theorem, you have leg squared plus leg squared. Now, I don't even use the negative because the hypotenuse is going to be positive anyway. But if you are using it, make sure the negative is in parentheses and you're trying to find the old hypotenuse. So this is 9 and this is 16. Anything squared is positive, so be careful with that negative. That's why I don't like to use the negative. These should both be positive numbers because you're squaring. So this is 25, square root, and it's 5. Always positive. It's positive 5. And it's always bigger than these legs. Use the triangle to find the 6 trig functions. So I kind of did too much writing right here. So we're going to go sine of theta, cosine theta, tan theta, and then cosecant theta, secant theta, cotan theta. These are the reciprocals straight across from one another. So according to theta, this is the opposite side. This is the adjacent side, and this is the hypotenuse. So sine is opposite over hypotenuse, -4/5, which makes the cosecant -5/4. Flip it. Cosine is the adjacent, remember we're doing SOHCAHTOA here. So the cosine is AH, 3/5. If you flip that, that's 5/3. And the tangent is OA, opposite over adjacent. That's -3/4. Let's just go ahead and double check our all scholars take calculus. We're in the 4th quadrant, right? So only cosine should be positive. It is. And it's reciprocal. See, right, remember this? Only cosine and secant should be positive. So cosine and secant are positive. Notice the other 4 should be negative. So of these 6, 2 should be positive, 4 of them should be negative if you're in a quadrant other than the first quadrant. Now, example 4 is not an ordered pair, but anytime they give you a ratio, they're also giving you 2 sides of a triangle. So whether they give you an ordered pair is 2 sides of a triangle, or if they give you a fraction, it's 2 sides of a triangle. So let's write this a little bit bigger. Cosine is negative 5 over radical 29. In SOHCAHTOA, cosine is adjacent over hypotenuse. So I'm going to write the word adjacent over hypotenuse in this problem. Do you know what quadrant this is in? Look in the problem. Does it say it? Theta is an angle in standard position whose terminal side lies in quadrant 2. Very important that you read this. So I want you to draw a triangle in the second quadrant. Now when you do this, you kind of have to do it like you did here. You got to go from the origin and shoot a hypotenuse out into the quadrant like this. Now, you always form the triangle with the closest, right here, connect the point to the closest x-axis. Closest x-axis to form your right triangle. So this is the x-axis, this is the y-axis. Never ever go to the y-axis. Go to the closest x-axis, form your right angle, and throw in theta. According to theta, this is the adjacent side. This is opposite, and this is hypotenuse, correct? Next two, straight across is opposite. So in this problem, it said cosine of theta, they gave you the adjacent side, which is negative 5. That makes sense because we went left, so it should be negative. And they gave you the hypotenuse, which makes sense that that's positive because it says that the hypotenuse is always positive. Now we're going to find the opposite side by doing the Pythagorean theorem. So remember, it's leg squared plus leg squared equals hypotenuse squared. So we don't know one of the legs. We don't know the opposite leg. So we're going to call this y, because that is the y coordinate. And then we know our x is negative 5 squared, and we know our hypotenuse is radical 29 squared. So we have y squared plus 25 equals 29. So y squared equals 4, and y, if you square root, is 2. Now this could be a 2 or a negative 2. The legs can be positive or negative, but the hypotenuse has to be positive. But in this case, because we're going up, it is positive, because it could have been positive or negative 2. But we're choosing the positive because it went up. Now that you know all 3 sides of the triangle, by doing the Pythagorean theorem, we're going to find sine of theta, cosine theta, tan theta, and the reciprocals, cosecant theta, secant theta, and cotangent theta. But before we do this, they gave us one of them. Remember, they said cosine was negative 5 radical 29. Looks like they're not rationalizing, so I guess we're not going to. We might as well fill it in. That was given. And then the secant is the reverse or the reciprocal of that. So that's 2 of them without even doing any triangle work. So that's adjacent. Look at that. That's adjacent over hypotenuse. Now we're going to do sine. Sine is opposite over hypotenuse. And if you flip that, you get 29 over 2. Tangent is opposite, which is 2, over adjacent, which if you flip that, it's negative 5 over 2. Let's double check our all scholars take calculus. In the second quadrant, now we're in the second quadrant, only sine is positive. Notice in this quadrant, we are in the second quadrant, only sine and its reciprocal should be positive. See how they're both positive? And the other 4 should be negative. That's your notes for Wednesday, 425.